Okay, class, today we are going to be working on proofs, and we're going to start off by converting flowchart proofs to two-column proofs. So take a moment and read the first example, where we want to, given that this is a median and these two angles are congruent, that these two triangles are congruent. And so we are given the flowchart, and we're going to convert that flowchart into a two-column proof. And when we do proofs in class, we're going to be sticking with the standard two-column proofs. So here's my diagram, and I'm just going to write in what we know. So we were given that these two base angles are congruent. Okay, and I know that this right here is a median. So I'm going to take my two givens, and I'm going to put those in line 1. So MP is a median, and I'm going to squeeze in angle N is congruent to angle Q, and the reason is that's the given. So we're always going to start off with our givens on our first line. Okay, so then what we're going to do is we're going to brainstorm ideas to fill in the middle steps here. So being that this is a median, I know that NP is congruent to PQ because that's the definition of a median. So my second step is NP is congruent to QP, and that is definition of a median. Okay. And I also know that if in a triangle you have the base angles congruent, then those sides opposite are congruent, and that's the converse of the isosceles triangle. So I'm going to write MN is congruent to MQ, and that's the converse of the isosceles triangle conjecture. Okay, so now I have a side, an angle, and a side in this triangle congruent to the corresponding side, angle, and side of that triangle. So I know I'm going to use the side, angle, side shortcut to show that these two triangles are congruent. Now triangle MNP, so triangle MNP is going to be congruent. Well, this angle corresponds to that angle, so that's triangle M. And then triangle, going back to the first one, we want to write it MPN. So MPN would be congruent to MPQ. Okay, so we started off with our given, we've written our middle steps, and we've gotten to our conclusion. And remember, in the original problem, we did want to prove this statement, which we did. Okay, so let's go on to the second one and take a moment to read this. Pause it if you have to. And again, we are going to convert the flowchart to the two-column proof. Okay, so here's our flowchart. So I'm going to take my givens, and I'm going to write them down. AE is parallel to CD. And B is the midpoint, and that's the given. So B is midpoint of CE. Now, since these two statements have the same reason, I can fit them into one line, or you could write each statement in a separate line and have the same reason twice. Both would be okay. So I know that AE is parallel to CD, so I'm going to write that down. And B is the midpoint of CE, so by definition of a midpoint, I know that CB is congruent to BE. So CB is congruent to BE, and that is definition of a midpoint. Okay, so what else do I need to know? Well, I ultimately want to prove that this triangle up here is congruent to this triangle down here. So I have a side, and you should be able to recognize that angle. And so I know ABE, so angle ABE is congruent to angle CBD, and those are vertical angles, VA, so those are vertical angles. And remember, you do have to use the 3-letter naming scheme for those angles. So now I have an angle and a side. And so now I'm going to use the fact that these are parallel lines. If you have parallel lines cut by a transversal, you know that these alternate interior angles are congruent. So angle A is congruent to angle D. So angle A is congruent to angle D. And if you look at the flow chart, they're using angle E is congruent to angle C, because those are also parallel lines cut by a transversal. So I'm adding in one extra thing here. So angle E is congruent to angle C, and those are alternate interior angles. So now I have an angle and a side and an angle. So I know that these two triangles are congruent through the angle side angle congruent. So I have triangle ABE, which is what we're trying to prove. So ABE is congruent to, well, A corresponds with D, and B corresponds with B, and E corresponds with C. So triangle DBC, which is what we wanted to prove. So we've converted our flowchart proof into a two-column proof. Okay, so now we're officially in section 4.6, which is on CPCTC. And what CPCTC stands for is that if two triangles are congruent, then the corresponding sides and the corresponding angles are congruent. So corresponding parts of corresponding triangles are congruent. That's where the CPCTC. So what that means, if you have a triangle over here that's congruent to triangle over here, and those angles are congruent, and those angles are congruent, and those angles are congruent. If these two triangles are congruent, then the corresponding parts are congruent, which is pretty much what we've already known. So what this is useful for when we're trying to prove things such as this. So here I want to prove that YW is congruent to ZX. So I want to prove that this is congruent to this. So to do that, I'm going to have to prove that this left-hand triangle is congruent to the right-hand triangle. And then once I know that the two triangles are congruent, then I can say the corresponding parts are congruent with this CPCTC. Okay, so what I want you to do is write down your givens and mark up your diagram. So go ahead and pause your video and do that. Okay, so I've written down my given, which is here, and I've marked up my diagram. The two that I've highlighted is what I want to prove, that they're congruent, and since M is the midpoint of those two, I know these two pieces are congruent. So I've drawn them in the diagram, so now I need to write down that WM is congruent to MX, and YM is congruent to MZ. And I was able to put those markings in because, well, that's what the definition of a midpoint is. Okay, so that's my reason. So I know those are congruent. And then I have my vertical angles in here. So I have angle YMW is congruent to angle XMZ, and those are vertical angles. So now I have a side, an angle, and a side congruent to the side angle side. So I know that triangle YMW is congruent to triangle, well, YM, so the YM side corresponds to the ZM side, and MW corresponds to MX, so MX. Okay, so my M's are in the middle. So those are congruent by side, angle, side. And then I need to fit in my last line, which got cut off on the screen. So now that these two triangles are congruent, I know that these corresponding sides are congruent. YW is congruent to ZX, which is what I wanted to prove. YW is congruent to ZX. CPCTC. The corresponding parts of congruent triangles is congruent. Okay, so I showed the two triangles are congruent, so I know all their corresponding parts are congruent, which is what we wanted to prove there. Okay, next problem. Here it is. Triangle ABC is isosceles, and CD is the bisector of the vertex angle. And I want to prove that this AD is congruent to BD. So I want you to write down your given statement and reason and mark up the diagram. So go ahead and pause the video. Okay, so I've written down my given statements, And since my triangle AB is isosceles and CD is the bisector, the vertex angle, I know that C is the vertex angle. And since it was bisected, I know those two angles are congruent. And since ABC is isosceles, I know those sides are congruent and these base angles are congruent. So now what I'm going to do is take the markings that I just wrote up and put them in here. So a couple of these things, these sides and these angles being congruent is, well, that's just the definition of an isosceles triangle. Okay, so I know CA is congruent to CB and angle A is congruent to angle B, and those are both the definition of an isosceles triangle. Okay, so now what I want to do is, since I want these two bases, so I have these two small triangles and I want to prove that they're congruent, and I have an angle, a side, and an angle, and the corresponding angle, side, angle. So I do know that those two triangles are congruent, so go ahead and write down those statements and pause the video. So ACD is congruent to BCD because the A's and the C's match up, and that's by angle, side, angle. And so then I know that AD is congruent to DB, and that's by corresponding parts of congruent triangles is congruent. So since I have two triangles, I know all their corresponding parts, including the AD is congruent to BC. Okay. Let's move on to the next. Actually, one thing that I realized I didn't actually write down is we said that those two angles up there were congruent. So what I really need to put in a line up here, and I'm going to write it down here since I don't have space, I know that angle ACD is congruent to angle BCD, and that is the definition of the vertex angle bisector, or just the angle bisector in general. Okay, so now that I know that those two angles are congruent, those two and those two sides, now I have the side, the angle, and the angle congruent statements so that I can use the angle, side, angle to prove that the triangles are congruent. But I had to write that in because I had to have the three statements proving the angle, the side, and the angle are congruent before I can say the triangles are congruent. So this really needs to go up there. Okay, so now let's move on to the next. Okay, so for this problem, I wrote in the givens, and I marked up the diagram with TP equaling AR, and big angle T is the congruent to big angle R. And I want to show that TA, this yellow hypotenuse, is congruent to RP, this green hypotenuse. So I drew in the two triangles that had something to do with, in this yellow one, it has the angle, the side, and then the yellow side, and the green side that I want to prove, and then I have this angle on that side and that triangle. So I do see that TR is in both the green and the yellow triangle. So I'm going to say TR is congruent to RT, and that's just reflexive. So that's what we say when something is congruent to itself in both of those. It's the obvious one. So now I have in the green triangle a side, angle, and side, and in the yellow triangle I have a side, an angle, and a side. So I do know that I have the side angle side conjecture. So I know that triangle PTR is congruent to, so P corresponds with A, and T corresponds with R, and then so it's ARP. So now that I have that those two are congruent, I can prove my statement that TA is congruent to RP. So TA is congruent to RP by corresponding parts of congruent triangles is congruent. So I know that PR is congruent to AT because they're both the hypotenuse of the corresponding triangles that are congruent. Okay, so what I would like you to do is try the last example, and then we can discuss it in class. I hope you have a good night.